Hello everyone. In this video, we shall solve question number 1 of exercise 1.1. Now this question is based on Euclid's division algorithm technique, which is used to calculate the highest common factor of two given positive integers. Your algorithm means series of well-defined steps which gives us the solution that we are looking for, that is the HCF in this case. Okay, so let's start with the first one. 135 and 225. So these two numbers are given to us and we have to find the HCF using Euclid's division algorithm. So the first step that we have to do is see which is the greater number. So obviously 225 is greater than 135. So the greater number becomes the dividend and the smaller number becomes the divisor. So we do the division here. 225, 135. So 135 one time goes and we would get 0, 9, 0. Okay, 90. So this is the quotient and this is the remainder. Okay, now first what we would do is, first step, we would write 225 as 135 times 1, that is divisor times quotient, plus remainder. So divisor times quotient plus remainder. Now remainder here 90 is not equal to 0. So we are going to repeat the step. So when we are repeating the step, in the second step, this becomes the dividend, 135 becomes the new dividend and 90 becomes the divisor. Okay, so 135 and 90, 90 ones are 90 minus and we would get 45, right? So now we can write this as 135 equals to 90 times 1, that is divisor times quotient, plus remainder is 45 in this case. So still we got 45, that is not equal to 0. So we are going to repeat the same step using a new dividend and new divisor. So now this would become the new dividend and 45 would be the new divisor. So 90 and 45. 45 times 2 is 90 and here we got the remainder as 0. So third step, we're going to write 90 equals to 45 times 2 plus 0. Now the remainder has become 0, so our procedure stops, and at this stage the divisor is 45, which is the required HCF. So we would say HCF of 135 and 225 equals to 45. Okay, let's do the next one. 196 and 38,220. So here clearly 38,220 is greater than 196. So 38,220 becomes the dividend and 196 becomes the divisor. And we need to perform the division the same way as we did for the previous one until we get the remainder 0. Okay, so let's do that. So 196 times 1 is 196. Subtract. You would get 6, 8, 1, bring down 2. Now let's try 196 times 9. Subtract and you would get 98. Bring down the 0 from here. Now 980. 196 times 5 equals to 980. And we got the remainder as 0. This is the quotient. Okay, so now we are going to write it as divisor times quotient plus remainder. 196 times 195 plus 0. So at this stage, 196 is the divisor, which becomes the HCF of the given problem. So HCF is 196. So in the first division itself, we got the HCF in this case. Let's see the next one. 867 and 255. So here 867 is greater than 255. So this becomes the dividend and 255 the divisor. Let's do the division. 867, 255. So 255 times 3 would be 765, and if you subtract you would get 201, 102. Now this we're going to write it as 867 equals to 255 times 3 plus the remainder. Now remainder here is not equal to 0, so we are going to continue the same procedure. So the new dividend would be 255 and the new divisor would be 102. So 102 and then 255, let's divide, times 2 gives 204, 151. So remainder is 51, again not equal to 0. So we're going to write this as 102 times 2, that is divisor, times quotient plus remainder. And now this would become the new dividend and this is 51 becomes the new divisor. So 102, 51 times 2. 2 ones are 2, 5 twos are 10. Now we get the remainder as 0. So this is 51 times 2 plus 0. The remainder has now become 0, so our procedure stops. And at this stage, the divisor is 51. Therefore, the HCF of 867 and 255 is 51. Whatever is the divisor at the last stage, when we get the remainder as 0, becomes the HCF of the given numbers. That's all for now. See you in the next video.